All right, we've made great progress in the technology since the first parts of the tape, which were filmed several months ago. One of the criticisms about the device was that it produced only DC at 5,000 hertz sine wave, and we have created an inverter which will take the high voltage DC and convert that into 120 volt 60 cycle sine wave to operate television sets and power appliances. First, this is another unit which we've made here. This unit is around 6 inches in diameter. It's right about 2 inches tall, and it is exactly an inch thick. This device weighs 12 ounces, and it certainly is a very elementary device. And the unit is now functioning. I'll show you the output of the device. This is a voltmeter set at 200 volts DC. See both the leads here on the voltmeter, and connect them directly, and the unit is putting out about 186 volts. Is that right, Michael?
Yes.
Can you read the voltmeter in the lens of the camera?
Checking.
Okay, 186 volts. It will fluctuate a little bit, and the unit still vibrates, as have the other units in question. Give you an indication of the power this puts out. This is a 100 watt light bulb, the standard lamp. And we have the electricity here coming right out of the wall. I'll show you this. Michael, this is a conventional 100 watt light bulb. Can you see that in the lens?
Yes.
All right. And give you an indication of the power. We can light a 100 watt light bulb directly off the leads. That is certainly as bright as it was in the lamp there. You're talking about at least 1 amp of power. 100 watt light bulb, which is getting quite warm. And for those of you who think that there is a direct magnetic coupling from something under the table to on top, we're going to move this device over here, certainly far away from the table, and repeat the same. There you go. 100 watt light bulb. Get that, Michael?
Yes.
Okay. And not only will it put out 100 watts to light a light bulb, but if we run it through the inverter, which is what we're going to do right now, see, the device is connected directly to the inverter. The relay is closed. There's nothing going into the inverter. And television set, normal television set here. And I'd like you to come around, Michael, and show the back of this television set. This is a regular 120 volt television set. It says right here, AC 120 volts, 60 cycle, 1.2 amps of power. So there's no portable power in the television. I'm going to run the cord straight over to here, plug it directly in to the unit, and we have power. Coming from through the inverter from this device. To show you the current output of the device. Remember the voltage before, you'll find that the voltage is only down a little bit. We're looking at, right now, it's at 170.5, so it's just down a little bit. Is that 171, is that right, Michael?
Yes.
171 volts even, and it will fluctuate just a little bit, but we're right around 171 volts. Okay. And we have our television set there. I will disconnect this device, show you that in fact the current is coming through the device. All right, now, to take care of this a step further, let me put this back on. Okay, now the inverter is in function. This is an ordinary drill which has a 3 amp draw at 120 volts. 3 amps, 120 volts AC. We'll plug this into the inverter here now, and you'll find that it will operate a heavy appliance like this. Three amps. This is a vacuum cleaner, which has an extremely, extremely high current draw when it is first turned on. There you go. Okay. Now, in case you think, again, we're still at our double output there, and we're going to take the device now and we're going to travel outside. You have to follow me in here. There's, again, with our same 100 watt light bulb. Watch your step there, Michael. That there is absolutely no magnetic coupling of any kind inside the home versus out here. We are a good 150 feet from where the original experiment was performed, and you will note that outside, again, we're looking at our 100 watts of electric power outside, a good 150 feet away from where the experiment was performed. It does get very hot. We'll return now, show you that, see, there can be no high current, there can be no close coupling through a high magnetic field. The unit would not operate outside. Device turned on again, and the unit is still operating. The television is in operation through the inverter. I want you to come over here, Michael, and get a look at the inverter so people can see. Oops, sorry, I seem to be making little mistakes here with this. I'm not really a filmmaker, just doing my best here. But anyway, the sound you hear is a relay closing inside of the unit. Take a look on the side of this. You can see in there very well. This is the major relay which produces the sound. This is part of the converter circuit here, which takes the 12 volt direct current, 5,000 cycle output, and through the use of the resistors and so forth, and then this major conversion transformer produces the 120 volt sine wave, the 120 volt 60 cycle sine wave that is necessary to operate appliances. Obviously, the unit produces a minimum of 3 amps, but once it's gone through the inefficiency of the converter or the inverter, so it more than likely is putting out 4 amps or so when we're using these devices. Also, the current draw of these devices when you first turn them on is probably significantly more than the 3 amp standard output that's coming from this unit. but there's nothing inside the inverter that could contribute to the creation of electricity, obviously. This unit is not receiving any kind of electromagnetic energy